Ok, siguiente video. Ya importamos, hicimos el tilemap, el video número 7, y ahora vamos a hacer el video número, sería 2, que sería agregarle movimiento que sea lineal. Después dice que se va a ver las animaciones. Entonces, empecemos con esto.
Okay, welcome back. So today we're going to continue where we left off. We have our player in the scene. We're going to add a few features to our player to make sure that everything is how we want it to be, so that we can start our movement. First thing I'm going to do, with my player selected, I'm going to add a rigid body 2D component. And then one thing I want to make sure I do whenever I add a rigid body component, if I hit play, you'll see what I mean. So there we go. So by default, gravity always works on rigid bodies. So I'm going to set my gravity scale to 0. I'm also going to there we go. So by default, gravity always works on rigid bodies. So I'm going to set my gravity scale to 0. I'm also going to set my camera background to something other than that Unity blue.
Así se va a caer. Mientras si le ponemos 0. De que estático ahí, ¿verdad? Correcto.
Blue. Nice gray would be good. Alright, cool. Also on my player, I'm going to add a box collider 2D. By default, this is going to be the same size as the sprite itself. I don't want that, so I'm going to zoom in close here. Now this is only going to be for collisions. This isn't going to be what we're going to use for our hurt box. We'll do hurt boxes with a different collider. So for this box collider 2D, I'm going to choose edit collider, and I'm just going to make it about the size of where we would expect our player's feet to be. So I'm going to change this down to about where we want our player's feet to go.
Okay. Box collider 2D. Y vamos a collider y solamente vamos a abarcarle las patas.
Sorry about that. Okay, cool. So that's where I want my collider to be. And if I click on it, I can see where I would expect my player to interact with the environment. Alright, so let's go to our scripts, and I'm going to make a new script. New. So right click in here, create, C# script, and before you click away from this, make sure you name it. I'm going to call this player movement. And let's open that up in Visual Studio. And I didn't have Visual Studio open, so it's going to take a second. I will meet you back here once that's done. Alright, so here we are in Visual Studio. I'm going to embiggen this a little bit here so that everybody can see what's going on. So first I want to create a variable for how fast the player is moving. I'm going to make this public so I can change it from the inspector. This is going to be a public float speed. The next thing
no, un momento, más que
I want to do is make a reference to my player's rigid body. So to do this, I'm going to make a private rigid body 2D, and I'm just going to call it my rigid body. I prefer long variable names that are nice and descriptive, because I oftentimes will leave a project for a while before I come back to it, and if I come back to it and I use these teeny tiny variable names, I never know what I did. So, alright, I like to use nice long names. And so then in start, I'm going to complete the reference to the player's rigid body by saying my rigid body is equal to get component rigid body 2D. Alright, cool. Another thing I want to make a reference to is a vector 2, which is how much I want the player's position to change. So this is going to be private as well. Vector 2. I'm going to call this change. Alright, so in the update method, what I want to do is I want to reset change to 0. So change equals vector 2.0, meaning every frame I'm going to reset how much the player has changed. Then I want to access if the player is pushing any of the buttons, left, right, up, down, W, A, S, D. And if so, I want to add to that change, and then I want to move the character by however much the change is, but I'm going to normalize it. So what normalize it means is, normally if you would be pressing both, say, left and up, you would have your horizontal velocity and vertical velocity added, so you'd actually be going faster than you need to. We're going to fix that right away. Okay, so I want to talk a little bit about our input here. So what I'm going to do is I'm going to take change.x, so the x part of change, and I'm going to set that equal to input.getAxis. And I'm going to show you the difference between getAxis and getAxis raw, because that's something that a lot of new people to Unity don't always understand. The axis I want to get is horizontal. And the horizontal axis is defined by default in Unity. We don't have to define it. And then I'm going to do something similar to change.y. So change.y is equal to input.getAxis vertical. And then what I want to do here is I want to just debug.log, because I want to be able to see what's happening so that I can explain. And I want to debug.log change so that I can print that to the console. So I'm going to save this script really quickly. Go back into Unity. And I want to debug.log change so that I can print that to the console. So I'm going to save this script really quickly. Go back into Unity. Choose the player as soon as this is done compiling. Choose the player, and then I'm going to negotiate a few of these and pull player movement onto it. Set my speed to Now, if I hit play, I'm going to pay attention down here to the console. And if I press left, you see how it kind of goes up. Now, this is a digital press, meaning it should jump directly from 0 to 1, but it's not. It's going from 0 to some decimal value up to -1. If I press right, it's going up to +1, but it's not going there immediately. Now, this can make 2D games like this feel kind of floaty because there's that acceleration between 0 and 1, even though there shouldn't be. If we're trying to emulate something that happened on the Nintendo or the Super Nintendo, it should be purely digital. It's either going or it's not. So, unless you're talking about Mario's Jump, but that's something else. So what I want to do instead of get access is I want to change that to get access raw. And get access raw doesn't interpolate between the two values. Instead, it just goes directly to whatever that new value is. So if I save my script,
Interesante, no va subiendo gradualmente, sino que cambia directamente -1, 1, 0, 1. Interesante.
Go back into Unity and hit play. Now if I hit any of those buttons, you'll see the difference between get access and get access raw. It goes directly, if you didn't know where to look, I'm looking down here. It goes directly from 0 to -1, 0 to +1. So there's no acceleration or deceleration, which is what we want for it to feel a little more snappy. Okay, cool. So back in our script here, I'm going to get rid of this debug statement. And then what I want to do, I want to make a new method. And the reason I'm putting this in a new method and not the update is because I want to be able to move the character from other places. So if I don't want to just use the keyboard, say I want to use on-screen buttons, by having this as a separate method, it makes it easier to do that. So I'm going to call this void move character. And for move character, what I'm going to do is I'm going to call the player's rigid body, and I'm going to set it to move towards the position wherever we currently are, plus the change. So to do that, we're going to say my rigid body dot move position. And the position we want to move to is transform.position, our current position in the scene, plus change times speed times time.delta time. Now, adding that time.delta time to that makes it so that rather than going, get something wrong there, change ambiguous, because it's vector 3. So I'm going to do this as a vector 2 then. Vector 2, new vector 2. So if I'm using transform.position, that's a vector 3, and change is a vector 2. So I'm just, actually, let's not do that either. Sorry if you're following directly. I'm just going to change from a vector 2 to a vector 3, and then I can do the way I want it to, just transform.position. There we go. Okay, cool. So to explain that again, I'm going to grab the position of the player. I'm going to add to it change, but if I just added change, I'm going to be adding like 1 in each direction every frame, and that's going to look super choppy. Instead, I'm going to add 1 times speed, which makes it 4, but then I'm going to multiply it by however much time has passed since the previous frame, which makes it a very, very small amount. So we're just going to be moving a small amount each frame. Alright, cool. So I'm going to save this. I'm going to pop back into Unity here. It's going to compile, and then I'll hit play. Okay, cool. That didn't work. Let's see what I did wrong. Oh, I never called move character, that's why. So I'm going to say if change is not equal to vector 2.0, meaning if there actually is a change happening, then I'm going to move character. So I needed to call that method. And change should be vector 3.0, and this should be vector 3.0 since I changed change to vector 3. So I'm going to save this, pop back into Unity, let's hit play, and let's try it now. So if you'll notice, the diagonal movement isn't faster than the left-right movement. Now, we got a long way to go, but here's our basic movement. The next step, we're going to make our basic animation. And the animation is going to allow us to have correct animation for left, right, up, and down. Alright, cool. So, if you have any questions, feel free to leave them in the comments down below. Otherwise, you can follow me on Twitter to find out when I post new videos. You can join my Discord server, where I'm chatting pretty much every day. The links to all of the assets are in the description. And
bueno, y este video era de ¿cuánto tiempo? Part 2, 11 minutos, y me tomó en hacer este movimiento 17 minutos. No es solo más. Entonces